not. Just so you get the idea of like how quickly you need to get your quizzes done. Yeah, that's what we'll do today.
Mainly over stuff like naming the ion and so did you go to modules on the preview? Oh, yeah, the preview has their. No. Because that is very to be honest.
I don't think I'm talking over myself. Okay. Everyone can see that? Okay, great. I can hear myself when I'm talking, so I don't want to do that. Maybe that'll work. I'll try that. Okay. Okay, so welcome everyone to your review session. I had a couple questions about the quiz. So just to reiterate what was asked, you have 6 quizzes this semester, and when is your first one? Tonight? Tuesday? Next week? So yeah, we'll get next quiz on Tuesday. So I posted some extra practice problems on the office hours page, and if you're in Altamos's class, and then there is a separate page if you're in Bengali's class where those are posted. Do you want to see where those are on Canvas? Yeah, okay. Let me. Okay, and then on the Canvas page. So if you go to courses. So if you are in Dr. Altamos's class on the office hours page here. And then underneath IA sessions, you have the video from your review session. Any notes that I write down on my iPad is what I have. And then any extra practice problems. All of those should just be linked. And then once I have the answers done, then I'll just post the answers there for that one. So that's where that's posted if you're in Altamos's class. And then if you're in Bengali's class, under the resources and contacts, I'm your IA. And then there is the link to the resource or review sessions. And so I'll just have all of this populated. So you'll have, again, the review recording, the notes, any additional practice problems, and then the answers once I have that situated. So that's where you can find both of those. Any questions on how to find those on campus? Usually the review session gets posted latest Thursday morning. And then the extra practice problems I'm hoping to have by like end of the week, to see how far you get on Thursday or Friday. And then we'll go from there and then I'll like try and make practice problems and post them afterwards. So you can check on the weekends for those. Okay, any questions on that? Okay. Okay. With that, is there anything that we wanted to see today to go over?
Maybe the content covered today will be.
Absolutely. So naming is something that you are required by both professors to look at on your own a little bit. So we can go over that right now. Has anyone not like named a compound before? Okay. So to go over a little bit of your naming, we have two ways that we can name compounds. Does anyone know the two ways? Yep. Perfect. Right, so you have ionic and you have covalent. What makes up an ionic bond? Good. This is a metal and a non-metal. Where do we find metals on the periodic table? Yep, this is on the left. Where are non-metals? On the right. Where else do we find metals? In the middle. And what do we call those? Good. Okay. What is unique about transition metals when we name compounds? Good. These require Roman numerals.
We have to memorize some of them by heart.
Slide.
Yeah, you have to memorize.
Also, make sure you know your Roman numerals. Sometimes I see a lot of people not know what 4 is. So just make sure you know what your Roman numerals are up until 5. And that's 1, 2, 3. 4, and 5. Alrighty, for covalent, what is a covalent bond? 2 nonmetals. And we said those are on the right. What do we use when we use, or when we're naming covalent compounds? Prefixes, right? Your prefixes are going to be super important when it comes to covalent bonding. When do we not use a prefix? When it's mono as the first element. Okay. There are a couple of exceptions, right? We don't call water dihydrogen monoxide. That is just water, right? Ammonia is one that you want to call ammonia. And that's water and ammonia. Oops. Right? Those are some exceptions to covalent bonds. But for the most part, you are going to be using your prefixes, and we're going to give you examples that you would use your prefixes for. What is a type of covalent bond that has names already for it? Yep. Yes, but I'm thinking of something else. No, polyatomic is what I'm looking for. So we do have polyatomic ions. Right, these are a type of covalent compound. They are always going to be 2 nonmetals, but they are not named by the prefixes. They have names already associated with them. When we're looking at a polyatomic ion, these will be given to you. Most of them will be given to you. It is for your benefit to kind of brief up on what some of them are. Some common ones, such as like phosphate or sulfate, or nitrate are usually the 3 that we use a lot. When you're looking at polyatomic ions, if you look at the name polyatomic ion, we have poly, which is many. We have atomic, which is, right, your atoms. And then ions, what does it mean to be an ion? It has a charge. Right, so if you see something that's grouped together, that's 2 nonmetals with a charge, it's going to be a polyatomic ion. Usually in compounds, this is going to be something that looks like this, right? Where you have a metal and then a polyatomic ion. Or you have a polyatomic ion that's positive and then a nonmetal. Okay, so that's where you're going to see some polyatomic ions there. They're also sometimes grouped together by brackets, depending on the charge that it is bonded with. Okay, any questions on just like general ionic versus covalent compounds? Yep.
So you said like the polyatomic ions, ammonia has is neutral charge.
No. So ammonia is NH3. This is not a polyatomic ion. This is just a regular covalent compound that is a neutral charge. Ammonium is NH4, and that has a +1 charge. Yep. Any other questions? Yep. Between like ionic and covalent? Yep. So for a ionic bond, what is an example of an ionic compound? NaCl, right? We love sodium chloride. Right, sodium chloride is going to be bonded, and I drew a bond between them. But what does sodium do? It gives away its electron, right? So sodium actually looks like Na+. And what does chlorine do? It takes its electron, right? So then chlorine actually looks like Cl-, right? And it has its 2 atoms. So sodium gives its electron to chlorine, so that's a transfer of electrons.
That's what makes it.
Nope. So sodium is going to hang out just as sodium, and it has in its outer shell 1 electron. Chlorine is going to hang out, and in its outer shell, it's going to have 7 electrons. So if you just looked at a chlorine atom, this is what it would look like, ish. So this electron here gets transferred to chlorine. And it's the transfer of that electron from sodium to chlorine that gives sodium its positive charge because it's losing that electron. And then that gives chlorine its negative charge because it's gaining its electron. Yep.
So if you had an element like magnesium that has 2 electrons, you need 2 chlorines.
Yes.
So it'd be like magnesium chloride with 2 chlorines.
Yes. Yep.
So basically, since chlorine's already like negative, it's a negative charge. It's transferring that negative charge to sodium, and sodium is transferring a positive charge.
It creates a positive and negative charge because of the transfer from sodium to chlorine. They start off neutral. Right? Because if we look at how many protons sodium has, does anyone know what element number it is? It's 11. So it's going to have 11 protons as an element, right? On the periodic table, does this have a charge associated with it? No. So how many electrons does it have? It has 11, right? For chlorine, this is element number 17. Does this have a charge right now? No. So it has how many electrons? 17, right? It's a neutral atom. When we turn it into sodium plus and chlorine minus, how many protons of sodium do we have? 11. How many protons for chlorine do we have? 17. We gave it a plus sign now. Does that mean we gained or lost an electron? We lost. So how many electrons do we have? 10. How many chlorines do we have? 18. Right now, our protons to electrons are imbalanced. That's what creates the positive or negative charge. Once those elements have the positive and negative charge, what do opposite charges do? They attract. And so that is what causes them to be bonded together and create such a tight bond, is because those opposite charges are attracting each other. Does that help your question?
Yeah. So like, I know that you said that once electrons do trade, then they're attracted because of opposite charges. But what causes the electron to go to the one first place?
There's concepts later on in the semester you learn about. It's called electron affinity. And so chlorine really wants to fill its outer shell. And so that want for the electron is what attracts it closer towards it, and kind of like picks it off from sodium. Sodium really wants to give up its electron, so it's looking to give it away. So because those are chlorine's looking and sodium is giving, they form a really tight bond.
Yep. Could you explain this exact thing about like covalent bonding?
So does that help the question about ionics? Yeah. So then for covalent bonding, we're not transferring our electrons. What are we doing instead? We're sharing. What's an example of a covalent bond? Water. Okay. So we have water here. We draw a bond with a line in between them to show that they are sharing electrons. This is like a dog and you have a leash between them, right? In a covalent bond, the dog is tethered to the leash and you are tethered to the leash. In a ionic bond, you let go of the leash and the dog is free to run around with his leash around his neck, right? In this case, they're sharing. So the electrons go back and forth between the bond between oxygen and hydrogen. What keeps these electrons together is that, you'll learn this again a little bit later, is that oxygen wants the electron a little bit more than the hydrogen does. So this creates a partial, negative and a partial positive. You don't need to worry about this too much right now. All right, but the charges are slightly different where they're being attracted to each other, but they're not full charges like in an ionic bond. So they're still attracted because there's some slight difference in charges, but they're sharing, it's not a transfer of electrons. They are being filled by overlapping. And so it seems like they're filled, but they're not fully filled. It's because they don't have the ability to like fully give up their electron.
When we say share, does that mean like, if we were to have three separate oxygen, hydrogen, and hydrogen atoms, they would have a certain number of electrons. But if they're sharing them, does that mean there's less overall electrons?
No, so oxygen is going to have 8 electrons, 6 electrons, 6. Hydrogen is going to have 1. So in total, we have how many electrons? We have 8. Again, this will make a little bit more sense when you start talking about bonding a little bit more. But each bond counts as 2 electrons. So there's 4 accounted for between the bonds. And then I drew them here. These dots each count for a single electron. So there's 4 total accounted for here. So there's 8 total electrons within the system. 4 are being shared between the oxygen and the hydrogen in both cases. And that satisfies the shells of both of them.
Where you got that number?
So on the periodic table, yep, so you can look at, this is slow. If you look at this here, right, we know that lithium is going to have 1, beryllium will have 2, boron has 3, 4, 5, 6, right? And then oxygen's number element 8, right? So then you have the 2 above it as well. So since that is going to start off as a neutral atom, we have 8 protons, 8 electrons that it's contributing to the system. The 2 in the center don't count. We're just talking about the outer shell. So that's why there's only 6 that we're working with for oxygen and then 1 for the hydrogen each. It only has 1 electron because it's element number 1. Does that help a little bit?
You just subtracted the hydrogens from
Essentially, yes. It'll make more sense when you start talking about like shells and all of that stuff as too. Does that help with difference between ionic and covalent bonds? Okay. Yep, there's another question.
Number is called like that H, like H2,
Mhm.
and it has to like be with 2.
Mhm.
It has to be with itself. I don't really get that.
Yep. So that one doesn't, you don't need to necessarily know why it's going to be a diatomic atom. You just need to know that it is one. So when we have diatomic molecules, this just means that it is the same atom bonded to itself. So there are, does anyone know how many diatomic? There's 7. Do we know which ones they are? Chlorine. What else? Chlorine. Bromine. Iodine. Yep. So those are the 7. So I'm going to go back to the periodic table again. So there are like mnemonic devices that you can use in order to remember those. My favorite way to use this is by looking at the periodic table because that's a visual tool that you will always have. In this corner here, we have nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. And this does make a 7 if you go over and down. There's only 6, so you just have to remember that your 7th is hydrogen. But I like seeing the visual 7 there to know that I have 6 in the 7 that it makes, and then you can go and just remember hydrogen by itself. But that just means that 2 hydrogens or 2 nitrogens, 2 oxygens are just sharing their electrons with each other.
Writing out the formula for a valent bond, you'll have to have that.
No. We'll do a couple examples.
Find like just a single hydrogen.
Yeah, but that becomes more of a radical hydrogen, so most of the time, like 99.9999% of the time, it's H2. Yeah. Does that help your question with diatomics? Yeah, those are just ones you need to know. Yep. Yeah, you don't need to necessarily know why they have to bond to each other. That comes later when you start talking about actual bonding and the outer shells of the electrons. Yeah. Yep. So let's do a couple practices with naming. As an example, right, like hydrogen bonds like this, and then nitrogen bonds like this, and it has to deal with its outer shells. So that'll come and make more sense later. G, it's calcium, or sorry, just give it away. It's Ca and then Cn2. Use it as the polyatomic ion. Mhm. Okay, so we have these 9 examples. Do you want to just take a little bit of time to work on this on your own and then we'll come back and talk about it? Yeah, okay. Feel free to talk to the person next to you and everything. Yep. Yeah, you'll always be given a periodic table and you'll given a reference sheet as well. Does everyone have this written down? I can pull the periodic table up. If that's, yeah.
I don't.
The 8s are for your polyatomic ions. Mhm. And your polyatomic ions, you'll be given a sheet that has the common ones on there. So if you,
For compounds, we just need to know the height.
mostly, yes. Yep.
Oh, did that make the
Yep.
For since why don't they file like? I can remember the previous.
So like hydrochloric acid, hydrofluoric acid, yeah. That's just because it's an acid, right? It's hydrogen and fluorine bonding, or it's hydrogen and chlorine bonding.
But she said I don't know where you're from,
Mhm.
but like the basic, like in a gas state, she just said how much you're clear. Or for. Is it not?
It-
She had like a little table on her slides.
Yeah,
And she wrote hydrogen fluoride, the binary, for the binary part. And I don't know.
yeah, I see.
like, So. And she wrote on her table, it's the hydrogen or HF, in hydrochloric acid, but she just said hydrochloride, it's not.
Yeah, it's just because it is it's an acid, so the acids have to.
Okay.
Just to make that.
Okay.
If we called it hydrogen monoxide, it's still correct.
Okay.
But yeah, yeah.
Okay, all right, thank you.
You know, a lot of names like. Oh, yeah.
Yeah, ionic and covalent are the most important ones. And then your acids will probably be given to you as an anecdote, just on your own. So like hydrochloric acid is just something that takes a lot, so you both for that.
Does every covalent bond with like acid? No, I think there's a point.
Like everything is either an acid or a base.
Hydrochloric,
If it has an H, if it has a hydrogen, it somehow, some way can act as an acid. So everything with a hydrogen, like, we just said acid, that's, but everything that doesn't have a, yeah, everything that doesn't have an acid or doesn't have a hydrogen also is acid. It just depends on how you define it, and you'll learn that later. Yes. Okay, did we answer all of our questions? Okay, what about A? What is A? Good. Right, so it's not sodium chlorine, right? You change the INE to IDE at the very end of chlorine. What about B? This is magnesium bromide. Again, right, it's not bromine, it's bromide. That changes the "ide." You don't need to say that you have two bromines because magnesium will always create a +2 charge. And so since it has a +2 charge, you know that, and bromine always creates a -1 charge. In order to balance out those two, you will need two bromines in order to have a balance of the two magnesium, or the 2+ on the magnesium. Yep, and that comes from the periodic table. So in the first row here, where you have the lithium, sodium, and potassium, that's your first row. Those will always create a +1 charge. In your second row, where you have beryllium and magnesium and calcium, those will all create a +2 charge. And if you skip the transition elements, because those have various ones that you can talk about, you come to the third row, those will all create +3. Chlorines will all create, or chlorines, carbons will all create +4 in that one. Okay, when you look at fluorine, that will always create a -1, right? So chlorine, bromine, and iodine, those will all create -1s because they're going to be taking in an electron over giving up an electron. Oxygen, sulfur, selenium, excuse me, those will all create -2. And then nitrogens will all create -3. Okay. Yep.
Why did you say like, why is like magnesium and two so like balance?
Mhm.
But then, so like, why it's like here two, but how come when writing it, I still don't understand why we wouldn't put the dye.
Yep, so if we look at magnesium bromide, what ion does magnesium come from? It's a metal. So you have magnesium, and then what's the charge on it? +2. Right? It always is going to create a +2. What is the ion that bromine comes from? It's a nonmetal. -1. How many of those -1s do we need? We need 2. But we know that bromine will only ever create a -1 charge. And we know that magnesium will only ever create a +2 charge. So we don't need to tell everyone that we need 2 bromines, because in order to create a neutral compound, you have to have 2 bromines. So you don't need to, that would be like redundant to say dibromine, because you need 2 in order to balance out the +2. Yes, yep, right. The same reason we don't need to say that we need 1 sodium and 1 chlorine in sodium chloride, because those are 1-to-1. In magnesium bromide, we need 1-to-2 in order to balance out those charges. Exactly, right? It's also an ionic bond. It's a metal and a non-metal. We don't use prefixes, and we don't use prefixes because they have given charges associated with them.
Oh.
Right? Does that help? Mhm. Any other questions on magnesium bromide? Okay, what about C? Yep, it's going to be phosphorus trichloride. We only have 1 phosphorus, we don't need a mono, and we have 3 chlorines. We still change this to an ide, and we have 3 of them, which is tri. Yep. Pretty much, yeah. The only time you're gonna see like an 8 is if it's a polyatomic ion. And that's either gonna be 8 or ite, usually.
And we're putting the prefix on this one due to it being not an ion.
Yep, so what is it? If it's not ionic, it's what's the name of the bond? Covalent bond. Yep, so because this is a covalent bond, we need to use our prefixes to tell us how many we need. Okay. What about D? Perfect.
See that?
Yes, yep. Right, on the quiz, I would look at this and I would say, okay, I see NO3, that looks like a covalent compound. I'm not sure what that means. Let me look at my polyatomic ions to see if I know what the name is of that. And I would see NO3 minus, right? It would look like this on your chart. And you can say, okay, I know lithium makes a +1 charge. That would be balancing out so that it's 1 to 1. So this must be the nitrate ion. Yes.
But it's a polyatomic ion, just like always two. Or wait, what?
Yep.
It's like two non-
It's always going to be two nonmetals, but it just has a charge associated with it, right? In the name polyatomic ion, it has ion, and ion means charge.
So there will ever be like a metal plus metal bond?
Right.
So we're not actually the name, right? The polyatomic.
Nope.
So why are they together if they still produce a charge?
That's above my pay grade to tell you. They just, they form this compound and they're very stable that way. Again, it has to deal with like energies and sharing of electrons. But you don't need to know why they form. You just need to know that they form. Any other questions? Okay, what about E? Right, I wanted to make this a little complicated. You have a metal and you have a polyatomic ion of phosphate. What charge does calcium make? What charge does phosphate make? -3. Right, so these do need to be balanced out, right? You can't just say 1 to 1 here. So it is going to be 3 calciums for every 2 phosphates. But because they have distinct charges, you don't need to say how much of each of them that you have, because you know that calcium will always have a +2 and you know that phosphate will always have a -3. So in order to write the name, you just have to use their charges in order to balance them out.
So you were to say phosphorus?
Nope, because you have, right, this is technically a ionic compound because you have a positive charge from the calcium and you have a negative charge from the phosphate. So you just name it as ionic compound.
So basically, you're only gonna be using the one putting something in front, like a die or something. If there's like, if one's like a variable, like, let's say, for example, those transition metal.
The transition metals use your Roman numerals. The prefixes come from non-metals and non-metals. So that's your covalent compounds. So like an F, what are we going to name this one? Good. This is carbon tetrachloride. Right, carbon and chlorine are both non-metals. This is a covalent compound. We don't need to say we have monocarbon, but we do need to say that we have 4 chlorines. Yep.
So what color, what, you said that we had to change.
You don't need to change anything. Nope, you can just say that this is calcium phosphate. You don't need to change it to say triphosphate or diphosphate, or tricalcium diphosphate, because they both have distinct charges.
So, for the carbon tetrachloride, the carbon and chlorine was negative ion.
Carbon can either be plus or minus.
Carbon's like 3 minus though, right?
Carbon is 4. So if you go from left to right, it's +4. If you go from right to left, it's -4.
So if it's with chlorine, then that becomes positive.
Carbon's a very, very interesting element. But in this case, it does make a +4 and chlorine's a -4. Any other questions? Yep.
CO or that's not, I know how it's just saying like four chlorine.
Mhm.
Actually, that won't affect the overall charge, right?
No, nope. So as long as the compound doesn't have a charge associated with it, like you don't need to worry about it having a charge at all. It'll tell you if there's a charge. You can assume that it has no charge. Any other questions? Okay, what about G? Calcium, what's the polyatomic? Cyanide. Right? You don't need to say you have two cyanides because calcium has a distinct charge of +2. And what's the charge on cyanide? Yep, cyanide is a -1 charge. Calcium has a +2 charge. What do we call it? Yep. There wouldn't be 3 cyanides because calcium has +2, right? In order to balance out, you only need 2. It would be a different metal if it was 3. What do we call H? We can call it water. What's its technical name? Dihydrogen monoxide. And then what do we do for I?
You said that, like, for the ones that don't have the prefix, they have a distinct charge.
Mhm.
Like phosphorus, trichloride, chlorine have a distinct charge.
Those do have a distinct charge, like chlorine still has a distinct charge, but for the phosphorus and chlorine, those are two nonmetals. So that is when it becomes a covalent bond and they're sharing, so it's technically not going to have a distinct charge, it'll have a partial charge. This is still an ionic compound for I, but this is with a transition metal instead of a full metal. So that's why I need the Roman numeral. In front of oxygen. So if there's only one, if there's only one element and it's not the first element. So if we were to look at CO, this is carbon monoxide. We don't have to say monocarbon because it's the first element in CO, but we need to say there's one oxygen because that's the second one. There's only one of them. Does that help?
But how does that even balance? I thought carbon was like 4+.
Right, so you don't worry about balancing here because it's a covalent compound. You only have to worry about balancing when it's ionic and there's full charges. Anything else? Okay, let's do a couple examples going the other way.
You automatically have that two subscript or subscript, that's what.
No, nope. So that's,
It's only based on the charges and then balancing.
Mhm.
Oh,
so like 2, you'll see for this one.
Oh, yeah.
The diatomics come more when you start balancing equations. So you have lead nitride, sodium hydride, and diphosphorus pentoxide. Periodic table, yep. Bless you. Yes, but what is it being bonded with? So what do you have there? Okay, did we get number 1? What did we get? PB. N. Is this it? 3 where? What's the charge on lead? What's the charge on nitrogen? -3. Do we need anything? No. What if this was lead 2 nitride? Where do we need subscripts? 3 for lead, 2 for nitrogen, right? Students like to say that you can take your charges, right, and put them at the bottom. And then it turns it to, yep, and then you just need to simplify. So in this case, right, in PB 3 plus and N3 minus, we put these here. So it's PB 3 N3, but we can reduce that down to PBN.
We don't simplify when it's covalent. We do this out.
Correct. Okay, what about 2? Perfect, right? Sodium is going to be +1. Hydride is hydrogen, right? Just with as its ide form or as its ion form. So that's going to be H minus. So it's Na minus or Na and H. So here, right, we see hydrogen. This is a diatomic usually, but we just have the 1. It doesn't automatically get a 2. Does that make sense for your question?
said that simplified was for the
Ionic, we do not simplify for covalent. Okay, and then what about 3? Right, di is 2, penta is 5. So it does not matter what those charges are because this is a covalent compound, so everything is going to be shared. That's something you should know, but you can just look at the periodic table and know. No, nitrogen is just going to be -3. Hydrogen can be plus or minus 1, yeah. It's +1, yep. So, right, all of your metals, your sodiums in that lithium, sodium, potassium, that's all gonna be +1. Your berylliums, magnesiums, and calciums are all gonna be +2. Ignore the transition elements. And then your borons are all gonna be +3. Carbon is going to be that ±4 transition state. And then your nitrogen is gonna be -3. Oxygen will always be -2. Fluorine will always be -1. The whole row. Yep, so, right, bromine, chlorine, and iodine will all be -1s.
So the transition depends on the oxidation.
Yep, transition depends on their oxidation number, and that comes from what they're being bonded with. So a couple of them have exceptions where like silver can only be +1. And then I think mercury is also +1. So some of them only really have one oxidation state, but most of them have multiple. Like manganese has 5, I think. Noble gases, don't even worry about, you probably won't get asked anything about them. But they have a full 8 outer shell, so they're not gonna react with anything. Does this help with naming our compounds? Yes, okay. I'll make sure to put some extra on the practice problems for this week.
Pretty much like covering what looks like high in like class.
We didn't talk about naming in class because that's something that she wanted you to do on your own.
Everything else though. They cover.
Yeah, we didn't cover moles, but I'll make sure that we have practice problems on that. Any other questions? My last 2 minutes, just to briefly touch on the mole. I know if you're in Gali, you'll learn about the mole a little bit more tomorrow. But just know that 1 mole is like saying 1 dozen, right? 1 mole equals 6.02 times 10 to the 23. 1 dozen equals 12. That number 6.02 times 10 to the 23 is its separate thing that equals 1 mole. So just make sure you keep those separate when you're doing conversions and all of that fun stuff.
Like is it 6.0 times 10 to the 23 grams or something?
It can be whatever you want. It can be 6.02 times 10 to the 23 puppies. That is right. You can have a dozen donuts. You can have a dozen houses. You can have a dozen whatever. You can have a mole of whatever you want. So that just depends on what the question's asking for.
Add up.
Molecules, grams, A's in a class. I don't know. Like you can whatever you want. Anything can be a mole of something. It doesn't matter what unit comes afterwards, but 1 mole equals 6.02 times 10 to the 23. Right, like 1 dozen equals 12. 1 mole equals 6.02 times 10 to the 23. We keep it separately in that way, then you'll be able to do your unit conversions when you have to. Okay, and then I do have practice problems posted already. This covers a lot of like percent abundance and just talking about physical and chemical changes, and like mixtures and stuff. So you can look over that. And then if there's anything you want to see additional practice problems on, feel free to just tell me and I'll make sure I get some problems in there. Or send me an email and I go through the notes at the end of every week, so I try to make sure I cover everything, but if I miss something, just let me know. Alrighty, it's 6:30. I'll let you go. Have a great rest of your Wednesday. And let me know if you need any extra help. Yeah, thank you so much. Thanks for coming. My email, it's just allison.getz@tamu.edu. 2 L's and an I. And it's also posted on a couple places, but so you can find that. But it should, if you just type in allison.g, I should pop up. Hi, were you the one that emailed me?
I did,
Yes.
yes.
I saw it in class and I was like, okay,
Okay,
I'll
yeah.
take it to this.
I was actually going to like a
Dolly, yep.
So when we transfer something like back from it, instead of like dividing like by the, 6.02, it's like 6.066 like times 10 to negative 23. Does he like put it as like 24th for some reason for moles?
Yes, so he said it was 24 because he was talking about, he had already done the conversion where he said, okay, I have 1 mole of this substance, which is this many like molecules or atoms or whatever he was talking about in that case, right? So he already did an extra,
So the 6.02 times 10 to 24 is how many like molecules are in 1 mole, which is equivalent to 1 gram.
not always. That depends, that is just specific for carbon.
Okay.
Right, hydrogen weighs 12 times less than a carbon atom does. So 1 mole of carbon is going to weigh more than 1 mole of hydrogen because,
Okay.
right, you can have 6.02 times 10 to 23 atoms of hydrogen is going to weigh less than 6.02 times 10 to 23 atoms of carbon. Because carbon itself already weighs more. 1 carbon atom weighs more than 1
So if
hydrogen
I'm
atom.
saying I had like a gram of hydrogen or something, how would I know how much that is?
That is going to be using your molar mass, and I think you talk about that a little bit more tomorrow.
Okay.
Yes, maybe it'll make sense a little bit more tomorrow. If it doesn't, send me an email, and then I'll let you know.
So, on the one, you mentioned one that was like transferring, you explained that a lot better, basically, so it's like, when you have 2 together, they transfer can you explain a bit more on that, like, why does one like transfer the electron? You said that one of them that has a positive charge once you get rid of an electron, and then the one that has a negative charge wants that electron. Can you explain that more in like in a way that I see, let's say on a question, like a test or quiz?
It wouldn't necessarily come up as a like question or test, like which one's transferring, which one, I guess it would only be like, okay, I have, right, I have this element and I have this element, and M has a +3 charge and X has a -2 charge, right? So in this case, metal M, and you have to fill in the blank, metal M is blanking its electrons,
Oh, transferring.
transferring its electrons, right? It's giving M, we're transferring from M two X.
And it'd be transferring 3 electrons, correct? It doesn't matter, just,
Technically here, it's transferring 6 electrons.
oh, 6 electrons?
Well,
Cause
it's,
you'd have to balance it.
you have to balance it, right? You're not, if you give +3 to X, now you're at +1, right? So you need,
Okay, like, I understand the balancing, like, I understand the balance, it'd be like you said, like, M3X. I
Mhm.
think you see what I mean, but
Yep.
like, I don't understand the 6, like, I don't,
so don't worry about how many electrons are being transferred right now. You just need to know that you need 3 X's to balance out the 2 M's that you have.
okay, I understand.
Yep, so just make sure that you're able to balance your charges, and that's all that really
Oh, and
matters
then
right now.
I guess that means that the amount of electrons being transferred is just you multiply the 2 and that.
Yeah, yeah.
Okay.
Right, so in the case of like sodium chloride, right, you have +1 and -1. How many electrons are being transferred?
Oh, just one.
Just 1, right, because it's pushing it from the sodium to the chlorine. In terms of magnesium chloride, yeah, that works. What's the charge on magnesium?
Um,
This is gonna be +2, and then chlorine's gonna be -1, right? So
So-
you need,
It's transferring 2.
yep, and how many chlorines do you need in your compound?
I need 2 chlorine.
You need 2 chlorines, right? So you have 2 electrons that are being transferred to the chlorine.
Okay. I think this makes a lot more sense. Like, I'm gonna be honest, like, in this class, I've learned mainly from like the homework and this.
Mhm. Yep, I think chemistry gets learned a lot through practice.
Yeah.
So the more you practice, the more you kind of understand the questions being asked and you recognize what's being asked. And that enforces the concepts you're learning in class.
Like, I feel like are you a TA or an IA?
I'm an IA, yep.
Is that like a
difference? So as an IA, I work more directly with the instructors or like with the professor. And a TA is like more of like a lab setting. So
like, that makes
I
sense.
just have a little bit more responsibility as an IA compared to a TA.
I guess.
It's essentially the same thing, but
Yeah.
I just have a little bit more.
TAs probably taught me more.
Sometimes that happens, but it's just the natural setting. I can be more personal with y'all. And I can go at your pace and answer your specific questions. I don't have to get through a whole bunch of information in an hour. So
Thank you.
Mhm.
Have a great day.
you too. Let me know if you need any help
Oh, you have these every Wednesday?
every Wednesday.
I just, the main thing is like, I just feel like